This video is going to be about electrons and kind of introducing electrons. So electrons are kind of the main thing involved in bonding between atoms. And because of that, right, electrons are negative and protons are positive. Because of that, the protons actually matter too, right? And it's kind of how these electrons and protons interact that kind of forms a chemical bond. Remember that neutrons are neutral, and while they will make an atom more massive, they actually won't affect how those protons and electrons interact. So different isotopes of the same element should react the same chemically. And so that's just kind of a side note. So let's talk about electrons. And really, I guess in this video, I'm just trying to get across this really weird concept. And I kind of want you to take my word for it, and I'm going to simplify it. And so this is kind of one of the basic things in quantum mechanics, which is that you can describe things as particles and as waves, right? And they're kind of both valid descriptions of the same thing. So if you look at an electron, we've always thought of them kind of as an electron, right? This particle, it's an electron. It's got a certain mass, it's got a certain charge, right? And it's got a certain location. Right, so that's kind of true. But you can also think of an electron as a wave. Yes, a wave. And so if you think of an atom with its nucleus in the center and one electron around it, so say it's a hydrogen atom, it's got one electron, you can think about that electron as a standing wave that's kind of just around the nucleus. That electron, it's like, well, where is the electron? It's like, well, that would be thinking of it as a particle. Let's think about it as a wave. So the wave is kind of just around the nucleus. And I want it to be a standing wave, so it's got nodes and antinodes. And then it becomes really weird, like how does this actually describe an electron? What is this actually telling us? And so the way I want to connect the two is to say that this standing wave that the electron produces tells you about the probability of an electron particle, right? That actual electron particle being in a given location. So I'm going to say that again. The standing wave of an electron, the wave description of an electron, is a way for us to think about the probability of an electron particle being in a certain location. Okay, so you can kind of think about the electron wave maybe as kind of like a mappy type version of the electron, which kind of tells you where the electron is going to hang out and stuff. And let's see. So the electron is going to be in this standing wave pattern. So it's going to have nodes and antinodes. The nodes will correspond to places that the electron really is just not going to be. And the antinodes will be places where there's a high probability of the electron to be. So again, we're gonna try to have it both ways. Both an electron as a wave, which kind of like tells us about the space and the likelihood of finding that electron particle in that space. And we know that standing waves only happen at certain frequencies, right? You can't have a standing wave at any random frequency. And so that's going to start to confine the different types of waves we'll have, which means we'll start to confine the different places that electrons are more likely to be. So let's start just looking at some pictures, and then we'll continue this in the next video. So I just wanted to show you some. So this is on the Wikipedia site for atomic orbitals. And this is a kind of a simplified graphic to show you kind of like a way to visualize what a standing wave electron would look like. Like, what is an electron? Like, well, what if I told you it was something that kind of looked like this? Now, it's not, right, it's a wave. It's not like a physical thing going up and down, but it's this way of describing the electron, right? And it's really telling you that, oh, it's really likely to be right around here where this antinode is. And for this one, it's like, oh, like here and here, right? But there's a node kind of in between right here, not going to be there, or really on the outside here. And here, oh, now we've got 1, 2, 3 nodes where it can be. And again, there's only certain forms that this wave can take, so there are only certain places where electrons are more likely to be. And we'll continue this in the next video. This is a pretty rough one.